The question goes like this. The diameter of the cross section of a water pipe is 5 centimeter. Water flows through it at 10 km per hour into a cistern in the form of a cylinder. If the radius of the base of the cistern is 2.5 meter, find the height to which the water will rise in the cistern in 24 minutes. This is the rough sketch of the water pipe and the cistern. The diameter of the cross section of the water pipe is 5 centimeter, which means the radius of this is 5 by 2. Water flows through it at 10 km per hour. That is, the speed with which the water is flowing is 10 km per hour. This means in 1 hour's time, the water which enters the mouth of this pipe travels 10 km distance to exit this pipe. Let's calculate the volume of water flowing in 1 hour. Pi r square h, pi can be taken as 3.14 and radius of this is 5 by 2 and height of the pipe can be taken as 10 km. Now that the radius is in centimeter, let's convert this length also into centimeter. Simplifying this, we get 19625 followed by 3 zeros centimeter cube. The question is asking us to figure out the amount of water flowing in 24 minutes, volume of water flowing in 60 minutes, 1962530 centimeter cube. Therefore, volume of water flowing in 24 minutes is 1 crore 96 lakh 25,000 into 24 upon 60, which gives us 78 lakh 50,000 centimeter cube. Which is equal to 78.5 meter cube. Find the height to which the water will rise in the cistern in 24 minutes. So this is the volume of water flowing in 24 minutes. This will be the volume of water in the cistern. Pi into r square is 2.5 square and h is what we have to find out, which is equal to 78.5 meter cube. That is, h is equal to 78.5 divided by, let's take pi as 3.14 into 2.5 square, which gives us 4 meter. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos.